Hey guys, welcome to another video of Cloud Deep Dive. In today's video, we will talk about how you can automate starting and stopping of your EC2 and RDS instances using AWS Instance Scheduler. So let's first understand why we need to automate start and stop of EC2 and RDS instances. Many times it happens that in our organization, we provision an EC2 or RDS instances for our testing purpose and then forget to terminate or stop these instances before going home after office hours or during weekends or during our holiday time. And these resources will keep on running and cost you money. So to solve this problem, AWS has a tool called AWS Instance Scheduler, which can help you to automate this process. So guys, now as we understand that AWS Instance Scheduler can be used to stop and start your EC2 instances, let's understand how its architecture works. So AWS Instance Scheduler can be deployed in your account by using a CloudFormation stack, and the stack is present here. If you click on this link launch in the AWS console, it will take you directly to your AWS account, and it will kind of take you to the screen from where you can start creating a stack. And we'll go through all the steps of these and what fields are required in a bit. So before that, let's go to this diagram where AWS explained that what all components it will be creating as part of this stack. Like it will create some rules in the CloudWatch, and those rules will be used to trigger your Lambda function. And what Lambda function will do, Lambda function will read all your EC2 and RDS instances in the accounts you will mention, maybe in the same account where you're deploying your stack, or in multiple accounts as well, and we'll show you in the demo that how you can use multiple accounts. And you can also it can also check in the multiple region in your account as well. So it will check all those EC2 and RDS instances, and there's some tagging goes along with that, which will show in the demo. So based on those tags, it find out that which schedule will apply to those EC2 and RDS instances, and accordingly it will start and stop this instances. So to give you an example, suppose we put a tag that this EC2 instance belong to my DFW office location, and for that DFW office location tag we store the data, the schedule in the DynamoDB table that my running hours should be Monday to Friday 9 a.m. to 5 p.m. So Lambda will pick up that schedule and apply on this. So if any EC2 instance it will find which is running after these office hours, it will bring them down. So that's how it works. Next, I want to show you in the documentation as well for the AWS Instance Scheduler. You can find two templates here. One template which you can launch or create stack in your main account from where you want to control. And if you have, suppose in your organization you have 20 different accounts, and you want to you have two options there. One, you can launch this stack in each account and create schedule in each account, and you can manage them separately in each account. Or the other option is you can have a central account which will be managing all the schedules, and child account EC2 and RDS will be controlled by this master account. And to do that, in the child account you have to create a role which give the permission to this master account that you can start and stop this EC2 and RDS instances. So to create that particular role, AWS provided a CloudFormation stack, and basically what this stack is doing is going in that particular account, it's just creating a IAM role so that this master account can start and stop these instances. Next, under deployment, it gives you all the steps which are involved in the CloudFormation stack. You can just go through these parameters, which we will be going in detail when we go into demo. It explains each and every parameter, what value you can put it in there. And in the bottom, you can see the stack of the child account as well. Here, launch remote stack. So once you click it will open and take you to the console, and you can launch that stack as well. So guys, now as you understand what instance scheduler is and what template you need to use to deploy it, Let's go to the demo part and see how we can deploy it and how it will be working to start and stop your EC2 instances. To do the demo, we need to do some little bit of setup. So our setup will look like that. We will be using two different accounts, account 1 and account 2. And we will use account 1 as a master account from where we control account 2 schedules like EC2 instances to start and stop. We will be controlling it from account 1. So for that, what all we need to do, we'll deploy our AWS Instance Scheduler template in account 1, and in account 2, we'll deploy the template to create the IAM role. And we will be using three different regions for this demo: US East 1, US West 1, and US West 2. And we'll deploy EC2 instance in each region, like 2 EC2 instance will use in account 1 and 2 EC2 instance will use in account 2, and in the respective regions which I mentioned in the slide. So let's go and log into the console and see how it works. So guys, I have logged into my account, and for this demo, like, we will be using two different accounts. So what I've done, I'm using two different browsers, Chrome and Safari, and I've opened account 1 into Chrome and account 2 into my Safari browser. So first, what we'll be doing, we'll be deploying our stack in the account number 2, which will create an IAM role. So for that, I opened the AWS documentation and went to the deployment, and on the bottom of the page you have stack, launch the remote stack in the secondary account. So I'll click on this launch remote stack, which will open the stack create stack option, and Amazon has provided the stack at this S3 location. So we'll click on next. So what this stack is basically doing, it will create a IAM role in your secondary account, and that role your primary master account will be using to start and stop EC2 instances. So we'll give this stack a stack name. We'll say stack version 2, and then you have to provide the account number of your primary account. So that means the account number of your master account from where you will be controlling, and that is that account number is used to create the trust relationship between your master account and your child account, so that your master account can assume the role and do actions on your behalf in your child account. So suppose my account number is whatever, this is my account number, I put it here and click on next. And here next thing is about the permissions tag. If you want to add some tags, you can add those tags. Permissions, this is pretty important, that if you have logged in as an administrator or you have access to create these roles, then you don't need to provide any role here. But if you don't have access to create any resource or any role in your account, then you have to provide a role name which have access to create these resources in your account. So this is important, that if you're logged in as a user who has access to create these resources, then it's fine, you don't need to provide anything. If you don't have, then you have to provide a role name which this stack can use to create these resources. These are advanced options which we don't need for these one, related to some policies and notifications and all the stuff. And after that, you can click on next, and you can review your options, and you can create this tag. And before that, you have to acknowledge that this particular thing as well. So I won't create it because I've already created one, because it take one create stack, it take a little bit of time. So to save the time, I created one stack with the same settings earlier. I'll show you that what all resources it creates. So this is the stack is completed, and it just created one IAM role here. When we click on that role, it will take me to the role, and you have to note down this ARN number. So copy that ARN number on your clipboard, because you will be needing this ARN number when you deploy the stack in your master account. And what this role is doing is just assigned a policy, EC2 Instance Scheduler remote policy, which is giving access to this role to access EC2 RDS, resource group tagging and system manager. So if you click on EC2, so as you can see that it's showing policies like it can describe this instance, it can start and stop this instance, it can create tags and delete tags. So there are some policies which will be required by that instance scheduler or by that Lambda. Just assigning those policies to it. So that's the only thing you have to do in your child account. Other than that, to save some time, what I've done, I've created two EC2 instances as well in this account. Right now they're in stop state, so let me go ahead and start those instances as well in the meantime. So one I have done in the Virginia region, US East 1, and the second one I think I have in US West 2 in this account. Yeah, so I'll start this one as well. Okay, so it will start. So now let's go to, and this I want to show that I don't have any tags assigned to these right now, so that we will be doing later and show you how. So you can see, oops, sorry. So there is no tags assigned to these EC2 instances as of now. So let's log into our master account. So like I said, in Chrome I have opened up, or I've logged in into my master account. Again, we'll go to our AWS documentation and we'll launch the stack from here. So when we click on the launch solution, it will open the stack in the CloudFormation. And the first page is just showing from where it's referring, and we can go to next page. First, we have to provide the stack name. So maybe we provide master stack version 2. Then you have to give the instance scheduler tag name, and this tag name will be used in your EC2 instances. So when you add a tag in the EC2 instance, you will give the key value as schedule, and your key will be scheduled, and the value will be the value which is stored in the DynamoDB table. And I'll show you when the DynamoDB table is created, so what value you will be using. So this schedule value is very important. Make sure that you note it down somewhere because you will be using it while adding those tags in your EC2 instances. Next, you will select what all resources like EC2 or RDS or both of them you want to do it. So for this purpose, testing demo purpose, we'll keep it EC2. Then these two options are related to RDS. So you want to schedule a Aurora cluster, yes or no, and you want to take the snapshots or not once it's stopped with the RDS instances. Scheduling enabled, yes. Then it comes to the region. So we have to give US East 1, US West 1, and US West 2. If you don't provide any region, then it will use only the current region. Like I'm deploying it from the US East 1, so it will take care of only EC2 instances in the current region. But if you want to cover all other regions as well, then you have to provide those list of those regions. Default time frame is, say, taking UTC. I'll take it to US Central. Then this is the close account role. So remember, from the child account we copied the ARN number, so we have to provide that ARN number here. So we copied it there and we provide the ARN number here. If you have multiple child accounts which you want to control by using this, then you can put a comma and you can provide all those ARN number from all those accounts. So the next field is this account. You want to schedule instances in this account? Yes, we want. So we'll keep it as yes. Next is frequency. Frequency talks about how frequently you want to execute your Lambda. Because like remember in our when we are talking about architecture, we talked about that CloudWatch rules will be triggering Lambda. So how frequently you want to trigger that Lambda to check whether they need to start or stop your EC2 instances. So here you can say set that frequency. For this demo purpose, I'll keep it as 1 so that it gets kicked off frequently, and we can see that in live action that is starting or stopping the EC2 instances. Next is the memory size. Memory size depends upon how many EC2 instances you will be using and how many EC2 instances you start and stop Lambda will be doing. For our demo purpose, because we are using only 4, so 128 is fine. But if you have more EC2 instances, then you have to choose your Lambda memory accordingly. These options are optional. We don't need to put anything. It's basically like storing the logs and all this information in the CloudWatch. So we can leave it as is. On this screen, you can provide some tags for your resources if you want. Permission is on the same lines what we discussed in the child, that if you logged in as administrator account or a user who has permission to create these resources like Lambda, DynamoDB table and CloudWatch rules, then you're fine. Otherwise you have to create a rule and give access to that rule for all these resources, so that this tag can this CloudFormation template can use that role to create these resources. And again, advanced options not required. And when you click on next, on the next page you can review all this information and acknowledge to this CloudFormation template and create stack. So I have already created one stack for this, so I won't do it here. I've already deployed, and you can see that it created all the resources required for this. So let me go to CloudWatch and show you what all we have. So if you go to CloudWatch, under rules, you can see that CloudFormation template created a rule with the AWS Instance Scheduler scheduling rule, and it has like triggering every minute. So the next trigger will happen at 4:11 GMT, then 4:12, 4:13, and it will be triggering this particular Lambda function. So it created that resource stack, created a Lambda function as well, which will get invoked by our CloudWatch events. And if you want to customize this Lambda function based on need, you can do that as well. So next thing, it created a DynamoDB table. So in DynamoDB table, it created 3 different tables. One is config table, maintenance, and state table. So config table is the one which has several rows. Like it has config row, which has all the configuration which we provided while creating the stack. Right, like we'll be using US Central Time Zone and what all regions I'll be using, right? And pros account role. So what role for the child account, the role we mentioned there, and all those information what I would provided while creating the stack, you can see it here. And if you want to update anything, you can update it from here as well. Then you will see there are several rows with period. So that this period talks about that, and you can add your own as well. So suppose I want to know what are my working days or what are my office hours. So if I open that, this period name office hours says that weekdays, Monday to Fridays, my office hours from 9 to 5. Anything outside of these days or this time is not my office hours. And similarly, they have bunch of periods like for weekends, working days, first Monday in the quarter. So you can declare as many periods as you want. Next is schedule. Schedule is basically combination of your period and your time zone. So like I've created a new schedule for myself, like it's DFW office hours, and what it says that I want to use US Central Time Zone, and I want to use a schedule named office hour. So period office hour. So my DFW office hours will use this office hour period, which says that that my office hour timing will be from Monday to Friday 9 to 5, and I want to use it for the US Central Time. Similarly, if you go with the Seattle office hours, it again use the same period office hours from 9 to 5, but it's using the Pacific time. So that means that the same office hour period will be applied, but it will be applied with the Pacific time zone. So that's all the information you have in the DynamoDB table, and from here you can declare your schedule at what time you want to start your instance or stop your instance, and then you can use these into your EC2 instances. So these names are quite important. So let me copy this name and I'll show you how we use it. Make sure that it get copied. Yeah. So now what we do, that remember I was talking about tags and tag values. So in config, we can see we give the tag name as schedule. So now let's go to the EC2 instance so that I can show you what I'm talking about. So like in the child account, I created two EC2 instances in my master account as well, and they are in stop state. Let me start those as well. And what we'll do, we'll add tags to these instances and manage tag, add tag. And what does that mean? We'll add the key as schedule and the value as DFW office hour. So what Lambda, when we store or when we save this tag, what will happen? The next time when the Lambda will execute, it will go to the config, this table. It will check, okay, what all regions I need to check, what all accounts I need to check, okay, and what is my tag value. So it will say, okay, go to US East 1, US West 1 and US West 2 regions, check for all the EC2 instances with the tag key as schedule. So it will come to the US East 1 or 2 and whatever region we have mentioned. It will check all the EC2 instances with this tag value schedule SCH. I think I did a spelling mistake here, so let me just make sure that I'm using the correct one. Okay, it will check with the key value as schedule, and then it will check, okay, what value we have assigned to this key is DFW office hours. Then it will go back to DynamoDB table and check, okay, what schedule it says for the DFW office hours. So it will open the schedule. It will say, okay, it has to be central time and I have to use the office hour period. Then it will open the office hour period and it will check, okay, I need to keep it running between Monday to Friday 9 to 5. If EC2 instance falls up or outside of this time zone and these days, then I can bring it down. I can stop this EC2 instance. So that's how it works. So these tags are very important. Based on this value, it will check what schedule it need to follow, and this basically name of the schedule only. Here we are telling, okay, for this particular EC2 instance, use this schedule. So let me save it. So right now it's running. I assign this tag to it. Okay, I assign this tag to it. Now let me go to US East 1 as well. Assign tag here as well. Okay, so I assigned this tag to this one and that one. So now let's add these tags to our child account EC2 instances as well. So I'm going to this EC2 instance, add tag, manage tag, add tag, and save. And this is my second EC2 instance, and we'll add tag to this as well. So we have added tags to both the EC2 instances. Now let's go back to our master account. And since we added these tags, so see, the moment we added these tags, these EC2 instance goes into stop state. And let's check the other one as well. It was running. Sorry, where did the tag go? Okay, here you go. Just take a minute. So you can see that the moment we added the tag, Lambda kicked off and it stopped these EC2 instances. And let's check what happened. Did it kick off to our child accounts as well or not? So if we refresh it, you can see it's in the stopping state. And let me check the other one as well. Yeah, this one as well in the stopping state. So if we go to DynamoDB table and to the state table, you can see that all the 4 instances in the 2 in the master account and 2 in the master account and 2 in the child account, they are in the stop state, and you can see their instance IDs as well. So that's how Instance Scheduler can help you to start and stop your EC2 instances. You can just add these tags, and based on the tag value, it will pick up the schedule from the DynamoDB table, and within the schedule you have the period defined, that what is your office hours or what is your weekend or whatever you want to define. And from that time, if these instance time falls outside that window what you defined in that period, it will take action accordingly. So that's it for this demo, guys, for this AWS Instance Scheduler. If you like this video, please hit the like button and share it with your colleague, and please subscribe to our channel for more videos. I'll be posting more AWS product videos and new features and new things AWS is launching every week. So we'll be posting more videos, so keep watching. Thank you so much. Bye.